Hello friends, welcome to PLC programming tutorials. And after installing Automation Studio, you will get this type of interface. If you want to know that how to install Automation Studio for free, then you must check my previous video. The link is also in the description, so you can go and check it out. So let's begin our exercise. And the first question we have is code a ladder logic when x0 is on, y0 should be on, and when x0 is off, y0 should be off. So this is very simple ladder logic that we have to build. First I want to show you by a simulation that how this whole PLC works. So then we are going to build from scratch. So first of all I go to simulation and show you. Okay, so here we have a push button. So as you can see in the question we have x0 and y0. x0 are the contacts that is normally open or maybe normally closed depending upon the question, and here we have normally open contact, and here we have a output coil that is y0, and here is the sign of normally open push button, and here we have normally open push button, and this is the indicator. So here also we have an indicator over here. So just keep one thing in mind, that x0 are the contacts, it can be normally open or normally closed, and y0 are the output coils. So it's simple. So let's build it from scratch, and so as you can see, when I press this push button the output goes on, and when I release this the output goes off. So this is the first example that we have to build, and I stop this simulation. Okay, so I remove all these components. Okay, so first of all we have to add all the components on our blank screen, and for that first we have to go to electrical control JIC standard, and from here we have to add a power source, neutral, a normally open push button. We can also name the push button, but for now it's okay. And after that we have to go to ladder for AB PLC, and from here we have to add a rung. Rung is a place where all the ladder logics are going to form, and we have also to add a normally open contact and the output energizer coil. Now we have to add a input and output for the PLC, and for that go to electrical control IEC standard, and click on this plus sign, and click on PLC cards, and here we have the input card. Drag and drop it over here, and the output card over here. So I rotate it to the right so that it comes in the vertical manner. Okay, so I rotate this one also Okay, so we have the input and output cards for the PLC. Okay, so now we have to place all the components in their appropriate positions. Okay, so I connect the one end of the push button with the input 0 and other end of the push button I simply connect it with the 24 volts, and this 0 volt I connect it to the common. One with the input common and one with the output common. And I just forget one thing. I have also to add a indicator. So go to electrical control IEC standard and then output components, and here we have to add a signaling device. So I just drag and drop it over here. Transform it. Okay, so now we have to add. Okay, so now we will link this 24 volt with the one end of the indicator like this, and other end with the output 0. Okay, so now we will link the other end of this contact with the output energizer coil. And what we have to do now is that we have to associate this contact with the input 0 and this output coil with the output 0. So for that, double click on the contact and type over here I, and here we got the input 0, and we have to just click on it and click on this associate button so that the contact will associate with the input 0, and then close it and do same with this output coil. Search for the output 0 and click on this button, and we have just associate the output energizer coil with the out 0 and then close it. So we have made our first PLC circuit. So now just simulate. Okay, so when I press this push button, the output goes on, and when I release it, the output goes off. So we have successfully done our first question, that when X0 is on, Y0 should be on. Which means that when the contact goes on, the output also goes on. So when I press this push button, the output goes on and the input also goes on. So here we have the normally open push button. And also an indicator. So we have already added a normally open push button and also an indicator. So I hope you have understand. So let's move with the second question, that code a series ladder logic such that when X0 and X1 are on, Y0 should be on. So it is also simple that we have to only add another normally open contact between the first contact and the output energizer. So let's do it. Simply stop the simulation and now we have to add another contact. So for that, go again to ladder ABPLC and drag and drop NO contact over here, and I disable this contact, remove this link. Okay, so now link it with the first contact and the other end with the output coil. Okay, so now we have to associate, and also we have to add a switch also, that is normally open push button at the input. Because in the question we have to add two push buttons, and both the push buttons are normally open. So the first end we have connected with the 24 volts and other end with the input one. So we have added two push buttons, and we have to associate this NO contact with the first input 1. So I scroll it and we get this input 1 and click on associate, and we are done. So we have just made a series ladder logic, which means that we have to press the both push buttons in order to turn on the output. So let's simulate again. Okay, so when I press this push button, the first input goes on, and when I press another push button, the second input goes on, and finally the output goes on. So the output is controlled by the two push buttons. So it's simple. I hope you have understand. Okay, so let's move to the question 3. Let us code a parallel input ladder logic such that when either x0 or x1 is on, here I have done a mistake, y1 is on. So just stop this simulation and I should edit it. Okay, so either x0 or x1 is on, y1 should be on. So it's simple. Let's do it. So just I have to remove the links and drag this contact below the first contact and connect it together in parallel. Okay, so and this end with the output. So here we have done. So let's simulate it. As you can see, I press the first push button and the output goes on, and when I release it, the output goes off. And similarly, when I press the second push button, the output goes on, because the two contacts are in parallel, and by turning on one of them, the output goes on. So let's do it again. When I press the first push button, the output goes on, and when I release it, the output goes off. And similarly, when I press the second push button, the input goes on and the output goes on, and the indicator is turned on. So again, I hope you have understand. These are the simple logics. So finally, we have the last question for this exercise, and in the upcoming videos we are using timers and counters, so we are also performing latching. So the last question, that is question number 4, we have is code a parallel output ladder logic such that x0 is on, then both y0 and y1 gets off. So just we have to add two energizer coil in parallel, and I have to remove this input, the first input contact, because it is saying about the only one input, that we have to add only one input, not the second input contact. So I just remove this contact, and also the NO push button because we don't need it. Okay, so I have to add a output energizer coil. So I go to ladder for ABPLC again and drag and drop this energizer coil over here and link it with the first coil in parallel, and I also associate this energizer coil with the output 0. Okay, so I go to variable assignment and search for the output 1. Okay, so I just connect with the output 1. Okay, so here also we have to connect the output 1 with the, okay, so we have done. Okay, so now let's simulate it. Okay, so when I press this push button, the two output goes on, and when I release it, the output goes off. But this indicator is not working. So why does it not work? Just because that the circuit is shorted, and as wire has less resistance than the indicator, then the whole current is start flowing from this shorted wire, because this indicator has high resistance as compared to this wire. So to turn on the indicator, we have to delete this link and connect it over here, and we have done. So let's simulate it. So when I press this push button, the output goes on, and as you can see, there are two outputs and both outputs are turned on, and we have connected a single LED in both the output. So again, I hope you have understand, and we have completed the first exercise. So see you in the next video. Thank you for watching.